Scholars, I hope you're all doing well. Ms. Perez here again with our last lesson for this CircuitsADIDay. So today we are wrapping this whole ADI up, and we're going to be doing that by summarizing and writing a conclusion on everything that we've observed so far. So for today, materials that you should have open are both the classwork document from today and also yesterday's classwork document. Right, so you can go ahead and open that now. You might have to unsubmit from Google Classroom to be able to have access to your classwork document. That's fine. You can just submit it again by the end of this lesson. Okay, so gather those. So like I mentioned, today we're wrapping up. So they were going to be doing that is we're going to first do a quick do now. And we'll have a short little lecture, and then you're going to complete your independent work on the classwork document that you have. Okay, so Arduino, if you're in a live class, you can answer this in the chat. If not, just think to yourself, what makes a strong conclusion? Right, there's many things that can make a strong conclusion, but for our purpose, we want to focus on these three things. We're going to focus on claims, evidence, and reasoning. All right, so we're going to keep these three things in mind as we perform our conclusions for today. All right, so again, as just a reminder, investigative question was, how do conservation laws apply to simple series or parallel circuits? Okay, so in the aim for today is going to be able to write a conclusion based on this investigative question. All right, so before we move on, I just want to remind you of the key vocab words that you're going to be using to write up your conclusion. So just a reminder, voltage, which is the same as potential difference. Those two words are interchangeable. Voltage is what causes electric charge to move, right? And then current is the actual flow of electric charge. Resistance is an electrical quantity that reduces how much current flows in a circuit. And then a resistor is something that actually reduces the current in a circuit. And the light bulbs that we've been using in our experiments are representative, are resistors basically. Light bulbs are resistors. And then there's one new vocab word here called voltage drop. So voltage drop is a decrease of electric potential along the path of a current flowing in an electrical circuit. So you guys might have saw in your data that there's a voltage across the battery. I mean, you saw there was a voltage across the batteries, but you also saw that there was voltage across the light bulbs. And that's because the voltage is actually dropping each time it goes through a light bulb. So the potential energy in the circuit drops every time it goes through a bulb. Kind of like gravitational potential energy drops every time you go downstairs. The same way a light bulb represents like a step down, you could say. Right, so you can keep that in mind when you're writing your conclusion. All right, so I'm just going to show you a few minutes of this video that's going to help frame for us the importance of claim, reasoning, and evidence-based conclusion. Start here.
Hi, it's Paul Anderson, and in this video I want to talk about CER. It's a framework for making explanations in the science classroom. It's a skill that teachers should give their students, and students should have if they want to improve their scores on lab write-ups, on essays, or on...
Oops, technical difficulties. Let's start that again.
Hi, Hi, it's Paul Anderson, and in this video I want to talk about CER. It's a framework for making explanations in the science classroom. It's a skill that teachers should give their students, and students should have if they want to improve their scores on lab write-ups, on essays, or on big exams. But before we talk about CER, let's talk about science in general. In science, what we're doing is gathering evidence for investigations of the natural world. We're then coming up with explanations that are critiqued over time. But unfortunately, a lot of the time in a science classroom, the investigations are developed by the teacher itself, and the students are just going through a cookbook lab, and so we want to avoid that if we can. But also, we spend too much time on the investigation itself, on the variables and controlling the variables. And then when we get to the end of coming up with an explanation of what we learned, we kind of fall down on that point. And so the CER is a framework that makes this explanation making explicit. It was developed by Dr. Kate McNeil and Dr. Joe Krychek. I'll put links to some of their material down below, but it's an acronym. The C stands for claim, the E stands for evidence, and the R stands for reasoning. Sometimes you'll hear rebuttal added at the end of that. That's looking at somebody else's claim, evidence, and reasoning. But this is my model for how claim, evidence, reasoning works. Claim is an answer to a question that's asked. Evidence is going to be what you gather, empirical evidence that's gathered in the lab or through research. And then reasoning is going to be a logical connection between the evidence and the claim that you're trying to make. Now, students will generally do really good at the evidence gathering, but they fall down when it comes to this logical connection. And so a good tip is to make sure that your reasoning is based in some kind of a scientific definition, rule, principle. That's a way that in science we can all agree on that. Now, what should a teacher...
Okay, so we're going to stop there. So hopefully that was a good, you found that helpful, a helpful frame as to the importance of claim, evidence, and reasoning. Okay, so now we're going to be writing our scientific conclusion. So you're going to use this rubric that's in your classwork document to answer your conclusion and to create your conclusion. And also we're going to be using this to look at some sample material first, and we'll identify some glows and some grows for it. And then you're going to move on to doing your own writing. Right, so take the next minute or so to just read through this chart that's on the slide and also in your classwork document. You can pause now so you can read through. Okay, so now that you read through this, let's take a look at some work, and let's see how if we can prove any strengths or any improvements here. All right, you're going to take the next 2 or the next 3 minutes to do this on your own in your classwork documents. And once you're ready, come back so we can go through this together. All right, you can press pause now. All right, so let's look at some of these. So let's look at some strengths. So the claim here is easily identifiable. Right, so as so saying as the temperature increased, the number of seeds that germinated increased. But above 25 degrees Celsius, the number of seeds that germinated decreased. So that's the claim. Right, then there was a hypothesis that was here, so that's also good, it's clear. Limitations, so in the experiment were also provided, which is always a good practice to have. Something like a suggestion for future study is also good practice to have in a conclusion. But here we're missing the evidence and the reasoning. Right? So you should have noticed here that that there's no evidence provided, and then because there's no evidence provided, then there's no reasoning that connected the evidence to the claim. All right, good job. So, so like a core idea for today is that conducting and refining an experiment in order to explore the conservation laws within a series and a parallel circuit. All right, so for the remaining time in class, you're going to write up your conclusion in your classwork document and submit this to Google Classroom. So I'll make sure that we're all on the same page here. Here's where you wrote the strengths and improvements. So here in your conclusion, just write your claim, the evidence, and your reasoning using the rubric given above. And also make sure to have yesterday's classwork document open so that you can refer to your work from yesterday to properly respond to this. Right? That's all for today. Once you're done, don't forget to submit everything. And that's all. I hope you have a fantastic day. Goodbye.